Okay, so now that we have the two pieces of information we got from the calculator, I'm just going to kind of highlight those again, this and this. We can use those two zeros to write factors of this polynomial. And so here's the deal. We know that p of -8 equals 0. This implies two ways that x minus -8 is a factor of p of x. Okay. If I know one of them, I know the other one. If I know one of them, I know the other one. So I could rewrite this as plus, by the way, just for your reference. The other thing that I know is the same piece of information just for this 0. So I can say p of 5 equals 0 implies both ways that x minus 5 is a factor of p of x. What that means is, at some point, I can take this polynomial and divide it by this. I can also take this polynomial and divide it by this. I'm going to do one and then the next one, but there is a little bit of a key part of this, and I know that we had talked about this last lesson, but this is sort of the really critical stuff. So here we go. What I'm going to do is I'm going to start by taking p of x, and I'm going to divide it by x plus 8. So I'm just going to represent that. X to the fourth plus 3x cubed minus 39x squared plus 3x minus 40. And I'm going to divide that by x plus 8. Okay, so that's the first thing I'm going to do. That's this step number 2. So I'm going to see what I get. I'm going to use the box method. So x plus 8 here. I want p of x to show up in the box right here. So I have to put my x to the fourth here, which makes me have x cubed there. Then I have to have an 8x cubed there, which means I need to get, in order to get 3x cubed, I need to add a negative 5x cubed here, which means this is negative 5x squared. So then I have negative 40x squared here, but I want negative 39x squared. So I need to add 1x squared. So then that means that I have to have a 1x here, where I could just write x. Then inside the box, I would have an 8x here. So then again, I need to get rid of 5 of them because I want a 3x. So I need to subtract 5 x's, which means that I have to have a negative 5 there, and that leaves me with negative 40 here. And that matches the last term there, so that means that I'm done. So what I'm going to rewrite is p of x is, we could call it x to the fourth plus 3x cubed minus 39x squared plus 3x minus 40, or we could say it is x plus 8 times the dividend that I get out. So x cubed, sorry, the quotient is the vocabulary word, but you know what I'm saying. 5x squared plus x minus 5. Now, we can use this piece of information, that x minus 5 is a factor of p of x, but it's not a factor of this part because we've already used that part. So that means that we're actually going to take this part and divide it by x minus 5. So the next part we're going to do is, I'm just going to rewrite that, x cubed minus 5x squared plus x squared, plus x minus 5 divided by x minus 5. So that's what I'm going to do right here. So in the box, I want the top of the fraction, as I always do. So, got to have my x cubed here. I'm going to show that I'm dividing by x minus 5. So, to get that out, I have to have an x squared here, which means that I have to have a negative 5x squared there. That's what I already have right here, so I don't need to add any more, so I can move directly on to the next term, which is x. So I've got to have a 1 up here. And that works out perfectly here. I have a negative 5, and that matches here. So now I'm done with the division, and I can kind of erase some of the box. So I can erase all of this stuff and just kind of close this off like this. Okay, what am I left with? I want to rewrite p of x as, well, I had my x plus 8, and then I have my x minus 5. And then what's left at the very end is x squared plus 1. Now, I'm just going to do a little highlighting here. I have a factor. I have a factor. I have another factor. And then I have a quadratic. And remember, this was sort of our whole goal at the very beginning of this unit. We were like, okay, what we really want to do is we want to write a quadratic times some other linear factors. And that's exactly what we have now. Remember that what I'm solving here is equal to 0. It's equal to 0. It's equal to 0 way at the beginning. So what I'm doing here is I'm going to solve the equation that is equal to 0 now. Now what I'm going to do to get there is I'm going to apply the zero product property. It says, okay, x plus 8 is 0. That's fine. I also have my x minus 5 equals 0. And then lastly, I have my x squared plus 1 equals 0. So these two are quick. Whoops. I haven't. There we go. Okay. These two are quick. So minus 8 minus 8. X equals negative 8. I knew this right from the beginning of the problem. I recognize that, but I just want to be really intentional about how I'm writing my answers. Plus 5 plus 5. I knew this also. X equals 5. I knew that from the very beginning just from the calculator. But what I didn't know was this stuff here. Now what I need to do is I need to use a quadratic strategy. And since this is in standard form with b equal to 0, I can just get x by itself. So I'm going to subtract 1 from both sides, minus 1, and I get x squared equals negative 1. Now I'm going to say, okay, x equals plus or minus the square root of negative 1. Now you're thinking to yourself, but what you should be thinking to yourself is, I. So x is plus or minus I, because it kind of looks like an inequality. X equals plus or minus I, because I is the square root of negative 1. So this is my solution. I have 4 of them. Now, I have this one, I have this one, and then I have x is the positive I, and x is negative I. Both are solutions. Okay, so there are my 4 solutions. This makes sense because what I have here is a quartic polynomial, and the fundamental theorem of algebra says my answers, there should be 4 of them. The fundamental theorem of algebra says that I should have 4 solutions. They are here, 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 and here. I really just have 2 more example problems for you. I just wanted to show you the other 2 ways I might ask you to solve these problems. This one says find all zeros. And what a 0 is an x value that makes the polynomial equal 0. So this is not a different problem than saying solve the equation 0 equals x cubed minus 64. So this question, even though it says a very different set of words, is really the same as this question. So I just want you to know that that's true. So now what we're going to do is we're going to find the zeros or solve the equation that I just wrote right here. So the first thing that I'm going to do here is I'm actually going to not look at a graph, not even do anything. I'm just going to think about this. What happens if I add 64 to both sides? The only reason that I'm doing that is because x to the third is by itself. That's the only thing that's in there. It looks like it's going to be like a two-step equation. It doesn't look like it's going to be that hard. So what do I get? 64 equals x cubed. Now, you could take the cube root of 64 and get your answer. And what do you get when you do that? Put it in your calculator. Take a second. See if you can find the cube root button in the calculator. You should have gotten that x is 4 because 4 cubed is 64. So what that tells us is that one of our solutions is x equals 4. But here's the problem. This problem is a cubic equation. Because it's cubic, the fundamental theorem of algebra says I have 3 solutions. But we only got 1. So therefore, we need to use the factor theorem. Since we know x equals 4 is a solution, we can say x minus 4 is a factor of f of x. I'm calling it f of x because that's what it's originally called there. So what that means is I can take x cubed minus 64 and divide it by x minus 4. See what I get out, and then use quadratic strategies to solve my problem at the very end. So let's do this. That was like so motivational. I've never even said anything like that before. Okay, I'm dividing by x minus 4. I should do that in blue. Okay, that means that I have to have an x squared there. That means that I'm going to have a negative 4x squared there. I don't want negative 4x squareds. I want 0x squareds. What do I have to add to get there? I have to add 4 more x squareds. That makes me have a 4x here, which makes me have a negative 16x there. But I don't want negative 16x. I want 0x's. So I have to add 16x's, which means that I have to put a 16 here, which means that I have to have a negative 64 here. That works out because this matches this. So I'm done with the division. What do I have left? I have that f of x is now written as x minus 4 times x squared plus 4x plus 16. Now, if I'm solving this equation, it's equal to 0 because that's what I wanted to do up here. So now I knew this already. I used this to get this answer. So I don't need to use that again. I do need to solve x squared plus 4x plus 16 equals 0. Now, this is a quadratic, and so now I have to go back to my unit 4 strategies. I have to be like, what am I going to use? I'm going to complete the square. I'm going to factor. I'm going to use the quadratic formula. Let's complete the square. So, got to have half of my b term here, 2x and 2x, which makes me have x and 2 and 2, which means that I have to have a 4 here. But I don't want I don't have 4, I have 16, so I have to take away 12, so subtract 12 on both sides. So what do I have? I have x squared minus plus 4x, sorry, plus 4 equals negative 12. So x plus 2 squared equals negative 12. X plus 2 equals plus or minus the square root of negative 12. You should be like, aye, right, everybody? I really need people in class. So x equals negative 2 plus or minus the square root of, I times the square root of 12. Here are my two answers that are left over. So I have this answer from the very beginning. I keep pointing to it, and then I have these two more. So this is all of my answers, and the reason that I know that is because of the fundamental theorem of algebra. I looked at the degree of the polynomial to figure that out. Then I used polynomial division once I found one solution to get to the point where I had another quadratic to work with, and then I applied the zero product property. And then I said, okay, now I have strategies and I can solve my last answers. So that's that. I just have one more example for you. Very similar problem. I'm just going to show you one more way I might ask you the problem, ask you the question, and then you can go from there. So what I told you this time is what the polynomial is. I'm asking you to find the roots of the equation. Roots of the equation are really the same as solutions. It's just another fancy vocabulary word that is annoying to deal with, but it's just another way of saying solutions. So what we're really doing here, surprise, is solve x to the fourth plus 3x squared minus 4 equals 0. This is not that different from what we've done so far today. What we do have here is we have two what we call hints. And so what this says is I can tell you two answers to this polynomial already, and we can use the factor theorem to give us our two factors. So x minus 1 is a factor that comes from here. X plus 1 is a factor comes from here. So one by one, we're going to take p of x and we're going to divide it by this factor. Then we're going to get the result and we're going to divide it by that factor. Then we're going to have a quadratic that we're going to solve for 0. Remember, this polynomial is quartic, so we're going to have 4 solutions. Okay. I'm going to ask you to start doing this first, and then you can watch me as you get stuck, or check your work at the very end. Okay. So I'm going to start by dividing p of x. Why am I still highlighting? P of x by x minus 1. It doesn't matter which one you do first. Yeah, it doesn't matter which one you do first. That's just a true statement. Okay, so x minus 1 is what I'm dividing by. I'm going to put p of x inside the box, so I have to have my x to the fourth here. So that means I have x cubed there, which means I have negative x cubed there. I don't want negative x cubed, I want 0x cubed, so I have to add x cubed there, which means that I have to put an x squared there, which means that I have to have a negative x squared there. But I don't want negative x squared, I want 3x squared, so I need to add 4x squareds. So then I have to have a 4x up here, which means that I have to have a negative 4x there. But I don't have any 4x's in there. I don't have any x's at all, so I need to add 4x's there. So then I need to make another box, actually. So then I need a 4 up here, and then I need a negative 4 there. This matches this, so that's how I know that I'm done. Then I'm going to rewrite p of x. So I have x minus 1, and then I have x cubed plus x squared plus 4x plus 4. Then I'm going to take this part and divide that by x plus 1, because I haven't used that one yet. So let's do that. Okay, got to have my x cubed here, so I have to have an x squared there. So then I have to have an x squared here. That's perfect. That matches this, so I can move directly onto the next term. So I can put my 4x there, then I can put my 4 there, then I can just put 4 there. And look, I'm back to the same thing. So this matches this, so that means I'm done with my division, and I can actually even erase some of the box. It's like a fun adventure. Okay, so I had x minus 1. Then I used x plus 1. And what I'm left with at the very end is x squared plus 4. Okay, I'm solving the equation equals 0. I can apply the zero product property, and I can say there's one solution. There's the other solution. And now I have x squared plus 4 equals 0. This is the part that I don't have solutions for yet. Even back at the very beginning, I was able to get my answers just by looking at this information, and so I know that this is not exciting and this is not exciting. But this is. Why would I subtract 2? 4. There we go, minus 4. Okay, x is equal to plus or minus I times the square root of 4. What's the square root of 4? The square root of 4 is 2, so I can say x equals plus or minus 2i. So what are my 4 solutions? I know it looks like I only have 3 boxes, but there are 2 solutions here. There's a positive and a negative. So I suppose at the very end of the problem, I should say x is equal to 1, negative 1, 2i, and negative 2i. There's my 4 solutions, the long list, and I'm going to just kind of zoom out so that you can see all of the work that we did. Okay, a couple of reminders. For the rest of this unit, you're going to see a lot of problems like what we're doing today. So if you are not 100% confident on what we did today, that is okay. You just need to get there by the end of like this week. Okay, so in 2 or 3 lessons, if you're not quite there yet, then it's like you need to figure it out. But for right now, it's okay if you're a little stuck. What we're going to do is we are going to, number 1, practice on all of these ideas. Going to do a bunch of practice. It's just a lot of like getting comfortable with all these strategies, all of these rules, all of these patterns, all of the things that you need to know. We will do a couple of things that will save some time on some of these problems, but we're also going to be I'm asking you to kind of get to the point where you notice the problems, you notice the patterns, and then you kind of figure out some patterns so that you are a little more efficient than if you didn't know all the patterns. We will be doing a ton of practice just because it's really not possible to get too much. We have plenty of time for it, and it's important to me that you are super confident by the end of this unit. And then we will be doing assessments as we go, as well as a unit end assessment. So just know that that's going to be coming. Today is just practice, but Thursday, I guess it's next lesson, and then the following, there will be some assessments. So that's that. I know this is kind of a lot of information. Do the practice, take a look at the key after you do the problems, ask me questions, come to the live sessions, do everything that you need to do so that you're really getting this, because even though you have time to figure it out, it's going to come up quickly. So that's it. Have a great day.